Hello guys, in today's video I want to show you how to measure home appliances current drawn, for example with an AC ammeter. Of course you got those pluggable watt meters and stuff like that, but they are digital, they don't show you very fast if the load is changing. So today I want to show you my way of doing it. So we've got a AC source. It can be some kind of transformer, for example. It can be your amplifier, for example. It can be anything, basically 230 volt mains or 120 volt mains. Doesn't matter. The frequency shouldn't be so high. It should be in mains frequency. Then we connect our appliance, which I have signed as a load. Everything is in series with 0.1 ohm resistors. So in this case, every 0.1 volt across it will equal 1 amp through it. So here 1 amp equals 0.1 volt drop across, and that's important. But this is too low voltage to do anything useful with it, to drive an analog movement, for example. So we have some kind of like 5 or 6 ohm winding across here, which bumps up the voltage. Then the transformer bumps up the voltage. On the primary we have the voltage that is across this shunt, and on the secondary we have this voltage but bumped up like 10 or 100 times. Then we rectify it with a bridge rectifier. We smooth it out with a capacitor. Here you can add a small inductance if you want to reduce ripple. Then we have here a calibration potentiometer, which in my case is a 10 kilo ohm potentiometer. And then we have an analog movement attached here. So this is how I have implemented the whole device. We've got the analog movement, which is recalibrated by me, repainted black, and the whole thing is signed there, so from 0 to 4 amps. Here we have the shunt and the input of the transformer, so we can see that the live wire goes in and then gets out. This is what we connect to mains, so a normal European plug. And then the output, I don't have socket, I have just 2 alligator clips and a protective ground if your appliance needs it. So you just clip those 2 clips around the prongs of the plug and measure the current here. Here in the back we have the rectifier that you can see here with a capacitor, and here is the small trim pot for calibrating, which is glued over so I won't touch it and recalibrate the whole thing. So let's right now measure an appliance that draws some amount of current. So in my example I will use a Dremel. It will create a huge amount of noise, so hopefully you can withstand that. And for example, when I will turn it on at a full speed, you should see a peak, a small little deflection there. Then it will go down because it will stabilize, and then I will try to load with small clip here around, small little pliers, the Dremel, so it will draw more current. So watch the needle. I think you saw the whole thing, that it bumped up nearly to 2 amps. So let me grab right now clip like that, with which I will load the Dremel. I will grab it, turn it on. You can see the humming noise, and it draws a bit more than 2.5 amps, 2.5 amps right now. So it clearly can measure high AC current, as you can see. Of course, it's not very safe. Don't try this at home. If you are building a circuit like that, be sure that you know what you're doing, because here we have 230 volt exposed. The capability of measurement of this thing can be expanded a bit. You can expose a bit of leads there and hook up your scope there if the current is not sine drawn by your appliance, which clearly is not in most cases. But it can measure very versatile types of current. I mean, you can see if the appliance that you connect it to draws very big amount of current or if it doesn't. I don't have any equipment, any analog equipment that could do the same resolution, for example, because here I have 10 volt AC, and 10 volt AC across here would be like 100 amps or 10 amps. So that's too big, so I needed to calibrate a small movement to do it for me. And this is like the best accuracy you can get from this circuit. If you would want to do it like 1 amp AC, which would be much more precise, obviously, you would need to have a full-scale deflection movement that has like less than 1 milliamp or less than 50 microamp, like full-scale deflection, which will be very, very difficult to get, and nearly any current drawn on the secondary will decrease the voltage, so it's not a circuit for measuring low currents. It's good because it's mains isolated on the other side, and the plus of it is that it can measure high currents. Basically, the current that you can measure is limited only by the power of your shunt, so it depends only on that. It's very nice to measure not only appliances like, for example, the Dremel that I showed you here, but you can also measure the current that is outputted by your amplifier. If you want to roughly check if the amplifier that you got or you will buy or you are testing and servicing outputs the right amount of power, you just connect this thing in series with the speaker and then crank the volume up to the highest position possible, or if you have dummy load, 8 or 6 ohm load, you can connect it up in parallel to the output and then measure the current drawn. So that's it for today's video. See you guys next time, and build a circle like that for yourself.